Okay, so I've just learned it's very awkward to try to do one of these and not have your students with you. Just trying to keep track of, hey, what questions might students have, and all the feedback you get from whether you're nodding your head or you're looking confused. So I'm just starting this over again. So yesterday we took a look at angles and angle naming conventions and some of those little details, and a lot of it was information we were familiar with. And today we're going to take a look at parallel lines and the angles formed by them. Now my guess is these are, again, tools that you were introduced to last year, if not previously, but we're going to step it up a notch in terms of the level that we can solve. So they're going to be a little bit more complex, and we're going to be a little bit more formal with some of our language, but the tools are in essence the same. So again, our focus right now is angles and those formed by parallel lines. Now if you don't already have someone already, I encourage you to have someone at the computer who can just be pausing the button video every now and then, just because I don't know exactly how long it'll take you on any given slide. So I would encourage that. So jumping right in, we want to formally define parallel, and that is two lines in a plane, that's our key word, that never intersect. We do have this symbol, two forward or two upper slashes. They might also be forward leaning slashes as well. You can also draw a third line through them to indicate not parallel. So as an example of this, I could give you the following. I could give you line CD in blue right there, as well as line BG, and we would see that these two lines, indeed, as they travel, are never going to intersect. And we do get that they're in a plane, because what I want you to imagine is putting that piece of paper on the top of this box. And if you were to rest a piece of paper on the top of that box, both of these lines would be in that piece of paper. That's what it means to be in a plane for geometry. Notation-wise, your statement might look something like this. Now yesterday, we just had rays. Now we're referring to lines. So notice that we have arrows on both sides. So line CD is parallel to line BG. Now, a point that I want to emphasize, yesterday we said that order mattered, right? We identified that to say ray DA is not the same as ray AD. And this had to do with the fact that our rays had an endpoint and a direction. But our lines go in both directions. So since they don't have an endpoint, it really doesn't matter. So that statement right there, CD is parallel to BG, I could say that by saying DC. Line DC is parallel to line BG. And that would be saying the exact same thing. Just because I switched the two letters on a line, it doesn't change the name of that line in terms of what I'm referring to, because it goes in both directions. So that's just something to be aware of. You do have that flexibility with lines. Now, we don't just have parallel, and our key in that is that we have in a plane, because we could also have what's called skew lines, which is two lines not in the same plane and do not intersect. Okay, and what I mean by that is this. I can still start with that same line CB, but now I want you to consider this line, BA. When we look right here, very clearly those two lines will never intersect. If you're not 100% sure about that, I can come over here, grab a book, so you can kind of see it more in front of you, and you can imagine this front edge right here, along with this back corner. These two lines, no matter how I turn this book, no matter how long I draw the extension of those whiteboard markers, are never going to cross. But there is not a single piece of paper I could lay that would encompass both of those lines. And so since they're not in the same plane and they don't intersect, we would not consider them parallel. Okay? So that's just a distinction we want to make. So even though we've got those two lines and they don't intersect, we would not be able to say that they're parallel. We would say that those two lines are not parallel. Okay? So we've got that distinction right there. Okay. Moving right along, we've got transversal, which is any line that intersects two or more lines in a plane. So we've got a figure right here. Remembered our naming convention from yesterday where we could put numbers in our angle spots to refer to the different pairs. And we're just going to go through our list. So this should already be written on your slide. We want to look at these groups of angles. Now in a perfect world, I'd poll you guys, get your input about which ones you think are where. So if you got someone at the computer, words, I might have them hit pause right now, take a moment, just discuss with your neighbor about which angles you think go in each of these spots, and then we'll go over it together. Okay, so maybe you took a moment, maybe you didn't, that's fine. Let's just go down our list. Exterior angles. Those angles are going to be 1, 2, 7, and 8. My recommendation, write down this list. Don't try drawing the circles up there because we're going to get a ton of them. So just write down in this list. We've got 1, 2, 7, and 8. The idea behind exterior is you are outside your pair of lines. Okay, you are outside the pair. In contrast to those four, we have our interior angles, which, lo and behold, are 3, 4, 5, and 6. Interior, they are inside our pair of lines. So we can make that distinction between our exterior and our interior angles. Now let's try to put it together. Alternate exterior. Okay, the exterior piece we know refers to the 1, 2, 7, and 8. Now if we want to try to make alternate, we now have these pairings. Okay, 1 and 8 are a pair of alternate exterior angles. 2 and 7 are a pair of alternate exterior angles. And what I want you to think about is this. They're exterior, they are outside the pair of lines. They're alternate, meaning they are on opposite sides of the transversal. That's the grouping we're looking for. So outside for exterior, opposite sides of the transversal for the alternate exterior theory, the exterior angles, and we get those two pairs. Similarly, we also have alternate interior angles. So we're going to do almost the same thing. We're going to move inside our pair of lines, and we're still going to alternate on opposite sides of our transversal. So if we know where our transversal line is, in this case T, we've got one on each side. So we've got these four groups of angles, and then we've got consecutive interior. These kind of group together a little bit differently. Interior, so we're thinking, let me get a frame. Interior, so we're thinking inside, and then consecutive, meaning they match up together. They're in essence next to each other. So you have this as a pair of consecutive interior angles, and 3 and 5 as a pair of consecutive interior angles. Now, I will tell you in advance, kind of like what I told you yesterday with supplementary and linear pair, I favor saying consecutive interior. That's the word I learned. That's kind of what my default in saying is. Our book introduces this skill by saying same side interior. Okay? I will accept either. I'm not picky. Same as the other, if I were to choose to say consecutive interior, you should still know what it means. But if you're writing your own problem or solution, I'm not picky about which response you put down. They're equivalent statements to me. So if you're reading it in a book, they're almost always going to say same side interior. I'm going to favor saying consecutive interior. It's just word choice. So either one there is okay. And then finally on our list we've got corresponding. And corresponding basically is this. We got 4 colors instead of 2. Corresponding, I want you to imagine right here. Green goes to green, purple goes to purple, red goes to red, blue goes to blue. Whole thing's a little messy, but here's what I want you to imagine. If I take the intersection of one of these and I slide it on my transversal to the other line, then they potentially match up on that next line. So 1 corresponds to 5, 2 corresponds to 6, 3 corresponds to 7, 4 corresponds to 8, and so on. Now, a point that I want to make clear in this diagram and what we've talked about, you'll notice A and B right now are not parallel visually, and I did not tell you that they were parallel. The parallel line angle relationships are a special case. They have a special property because the lines are parallel. These names exist for any sets of lines that are crossing. So just because you might remember, oh hey, there were some rules with parallel lines and these angles, you can still use these angle names, you just might not get that parallel line property, and we'll explore that a little bit more. So those names work for any situation of lines, not just parallel lines. Okay, moving on. By the way, that slide took me way too long to make, just tossing it out there. Line and L are parallel. They are drawn parallel. You may trust the picture. I'm telling you they're parallel. I'm going to make a prediction about angle 1 and 2. Go ahead and pause the video for 20 seconds and take a guess. And I'm hoping pretty obviously you either visually can see it or you remember it from last year that, hey, that angle 1 and that angle 2 are the same. Those two are going to have the same degree measure. If I come over here and tell you angle 1 is 20 degrees, then angle 2 is also 20 degrees. There is that consistency between those two values. So what I want you to do now is I'm telling you that angle 1 is 30 degrees, and based on what we've seen so far, go ahead and pause the video. I want you to find those other 8 values. So take a moment, pause the video. If you haven't already, as you are solving this, I want you to be explicit in terms of the rule you're using. So you have different paths to take to get all 8 of these. We're starting here. We know that angle 1 is 30. And you have a choice. You could say these two are a linear pair. So they add up to 180 and this must be 150. That is something you could say. You could say, hey, these two are vertical angles. So because they're vertical angles, I know angle 4 is 30. Also an option. You could come over here and say, hey, I've got alternate interior angles. They must be the same. So this one must be 30. Ignore the leaf blowing for the morning. You could keep doing things around. You could say, hey, these are alternate exterior angles. So I know this one must be 30. Maybe, hey, this is another linear pair, so this must be 150. Or you could say, hey, these are corresponding angles. This must be 150. Put the degree symbol there, and I don't know, let's just throw another vertical pair up there and make this 150. Did you need to necessarily say every single one of those? No, but the idea is any of these angles could work. You could have just gone linear pair, linear pair, linear pair, corresponding, linear pair, linear pair, linear pair. You could have used the same ones again and again and again. But the idea is all these rules and angle relationships work together. So depending on whichever one you see, as long as it's following its rule, it's valid. We probably all filled this in. And we probably all thought about how to fill it in a little bit differently. And that's okay. That's what's going to happen this year. We're going to have moments where we all end up with the same answer or similar answers, but the paths we took to get there are drastically different, and that is okay. Now, again, I want to reiterate the importance of you have to trust your math, not assume your picture. I've been saying that all year. We saw it again yesterday. Yes, this acute angle is 150 degrees. So it might throw you off because you say, hey, that looks smaller. It should have a smaller degree measure. Well, when we're given this detail, we trust our math and we don't assume in our pictures. So I just want to stress that again and again and again. You need to be in the habit of being confident in your mathematics so that you don't get tricked by a picture. Because it's easy to look at something like this and say it was more complicated than what we just did and think in your gut, oh, angle 2 needs to be smaller than angle 1, when that might not be the case. So just kind of keep that in the back of your mind. Okay? So, leave that up for just a second. What we're going to do, excuse me, still getting over that goal. We are going to look at the formal definitions of our theorems. So, straight up, this will be a bit of writing. Corresponding angle postulate in its entirety, written well, says this. If two parallel lines are intersected by a transversal, then the corresponding angles are congruent. Okay? And we probably remember that from our picture. We saw that when we brought 30 degrees down, right? If I have two parallel lines and I throw a transversal on there, if I tell you this is 100 degrees, we know that this angle corresponds down here. Arrows for parallel, because why not? And so we get that idea that if two parallel lines are intersected by a transversal, then the corresponding angles are congruent. This is the whole statement. After this moment, I never want to have to write that whole thing again. It is long, it is wordy. So here's my encouragement to you. As much shorthand as you can use to still clearly convey your message is okay. So I will never write that sentence again. Instead, I will write this. If parallel, then corresponding angles are congruent. Same idea, it has all the needed information. I'm starting with parallel lines, and I've got the if-then part, which is really crucial, and we'll explore that a little bit more in the next unit. But if parallel, then corresponding angles are congruent. What I want to stress with this shorthand, maybe you don't like symbols and you want to write angles congruent. That's fine. You can write as much or as little as you want so that you are comfortable with it. I like using symbol in my notation and note-taking. Some people don't, and that's okay, and that's where it'll vary based on our preferences. Here's what I want to stress though. If you forget the if parallel, then the rest of this is meaningless. Because remember, any sets of lines have the angle name, corresponding angles, but they are only congruent if you first have parallel lines, right? I can draw a pair of non-parallel lines right here, draw a transversal. These two angles, I didn't exaggerate that too much, let's go here. These two angles definitely are not the same value, even though they're corresponding. So there's just this idea that you need the if parallel part. So if you try to only write this, corresponding angles congruent, you won't get credit for that. You need the whole statement, okay? So we're just going to go down the rest of our list. Corresponding angles, if parallel, then corresponding angles are congruent. We also have alternate exterior angles. If parallel, then alternate exterior angles are congruent. Again, just some shorthand. I'm going to go a little quicker and give you a chance to write this at the end. Alternate interior angle theorem. Same idea. If I have alternate interior angles, they are also congruent. You hopefully are recognizing these patterns with the one slide that we had before. Now here's where it changes a little bit. Consecutive interior. They're no longer congruent. Look back at your picture, consecutive interior, when you had all those angles up there. Consecutive interior angles for parallel lines are supplementary. So, corresponding congruent, alternate exterior congruent, alternate interior congruent, and consecutive interior are supplementary. Okay? So that concludes the notes parts of today. Hopefully that wasn't too long. Now, there's 4 practice problems on this worksheet. I'm going to record each of those as a separate video. My encouragement to you is to take a few minutes to try each of those problems, and then what you can do after that is, maybe after 5 minutes you want to go ahead and look at number 1, play that video. Maybe you need 8 minutes before you play number 2. And kind of get a feel for the class. What I want to encourage you on, check with your groups, check with other groups to see if you can make sense of it on your own first. Obviously I realize I'm not here to offer some guiding questions, but I think there's enough power amongst all of you to make progress on these. And don't feel like you all have to be completed to go ahead and watch a video. Maybe 2/3 of you got question 2, and the other third aren't quite sure yet, but they made some progress. It might be worth it to go ahead and start. So you can kind of judge that with each other about when you're ready, and let whoever's been on the computer to make that decision.